Hi everyone. Uh, well, yeah, today, what should I say? On September 24th, I tried of doing a live broadcast and was unable to do a live broadcast. So today I figured out how to do live broadcast on YouTube. Anyway, so let's see. This is my way of logging in into Amazon. As of now, I have secured my AWS console account. Uh, And once I enter the password, I secure my AWS account using a YubiKey Bio. So this one requires me to touch this here, and like only if the fingerprint matches, I would be able to log in. And there are other versions of YubiKeys where you simply have to tap on a little circle. Um, for example, this one. Anyone can tap on the circle. It doesn't do any kind of fingerprint matching. But the YubiKey Bio um, does fingerprint matching. So this is what I used for securing my AWS account. This is how I would get prompted. And so anyway, this is my AWS account. As of now, my AWS account should not be hackable unless session hijacking. So I'm considering using a VPN when connecting to AWS. But yeah, later. As of now, because I don't have any revenue, I'm running a very one small server, T3 and medium, and yeah, like T3, the T2, T3, and T3A are burstable instances. That is, if there is a sudden CPU spike, the applications would still continue working, and then slowly there would be CPU credits. For example, I can show you this. Um, Of course, for this particular application, in the past 1 week, I had to run some, a lot of an application for figuring out the related podcasts. And kind of, if you see here in the graph, you can see that the CPU credit balance was at the max, 576. And then after I started the application, it was a long running batch job. All the CPU credits were consumed, and then there were no CPU credits. And after the batch job has completed, for some time the CPU credits did not get added. The reason being some extra CPU credits were used. And then slowly the CPU credits got accumulated, and now the CPU credits are at the peak. And yeah, so now and I don't directly SSH into the console. I rather use AWS Connect. So now I don't have any SSH keys to manage, and I'm not concerned about losing SSH keys or if some hacker would, if anyone would try to steal or anything. So anyway, yeah, I created some deployment scripts and everything, and I'll show you later. Like later I'll show you how I set up. But yeah, so this is, kind of I'm creating a little shell script. I created the script long time ago. Um, yeah, there are a bunch of different projects that need to be compiled and, kind of um, copied into different places. I'll show you what's happening in a bit. Now with this, it's gonna do a bunch of things in the background. Um, at a higher at a higher level, it copies a zip file, unzips the zip file, and then kind of compiles a bunch of microservices, the web application, and then copies the app settings. Um, there are a bunch of background services all of them get stopped, and the binaries get deployed and gets restarted, and then all the artifacts, like all the compiled code, gets zipped and copied over into AWS. So this is, like kind of what the script is going to do, and like it's going to take 5 minutes, 10 minutes, 15 minutes, 20 minutes, whatever. Meanwhile, I'll show you what I did regarding how I got my code into S3. So what I did was, like I could have used code build for the actual compilation and only uploading the artifacts into S3 and getting the artifacts from there. But the actual compilation takes 5 to 10 minutes, and code build provides only 100 minutes of free time per month. So instead, what I did was, as soon as, like I can show you, the details. When I publish into, when I commit code into GitHub, and for this particular branch, and if the events are these, and in the comment, if I say, if there is the word complete, only then um, the code build gets executed. What it does is very simple: gets the code, zips, copies the code into into S3. Yeah, zip, copying into S3. That's all. So, for example, if the word complete is not there, that is, if there is no feature complete, or like a version complete, uh, then this wouldn't happen. And the reason I'm not using code build is, I don't want to pay for extra code build minutes, because I have plenty of CPU minutes on my EC2 CPU credits on my EC2 instances. And then let's see. Yeah. So pretty much that's how the code is getting into S3, and what should I say, kind of yeah, the compilation process is happening here in the background. As I said, it would take 5 to 10 minutes. Um, yeah, and this is the code base. If you see, the code base is huge. There are a lot of things, and of course, some of them are things in kind of things in progress. But ultimately, there are a bunch of background processes for importing data, exporting data, cleaning data, figuring out related podcasts. Doing a little bit of. I mean, like I did. I have a kind of a overview of some machine learning techniques, for example, natural language processing. So in this, what I did was I used keyword extraction. That is, given some text, keyword extraction algorithms try to determine the important words in a given text. So based on that, what I do is I try to figure out uh, which two podcasts, based upon the description, based upon the title, could be more related. So that was the algorithm I used for um, like finding out the related podcasts. And then what I did was I have a bunch of microservices. Some of these are useful, and some of these are not deployed yet, kind of work in progress. Um, and for as of now, everything, all the database, the Solar instance, all of these are on the same server. However, in the future, if I want to scale, like if I want a read replica of a database, and if I want like the ingestion of data to happen on one database, and if I want the reads to happen from a read-only replica, that should be a possibility. So one of the architecture decisions was having a separate consumption microservice and an ingestion microservice. So when data is being read, the applications, the client applications, would connect to the consumption microservice. When data is being written, the data would be written into ingestion. And similarly, the databases were kind of sharded. For example, there is a volatile DB, and then there is a global database, and then there is the pod feed related database, and similarly Solar pod feed. Even with Solar, the ingestion and consumption are different microservices. So, for example, and like this way, I can scale horizontally. That is, like increasing the size of the instance or adding multiple instances. So this is one of the major design decisions. And then like this is something still in progress as of now. As you can see, I'm deploying like using a shell script. Instead, I thought like why don't I create a little deployment helper so that I don't have to figure out which microservices were updated, which were not updated. What if the tool determines what are the updates comparing with the previous release and the current release, and automatically deploys those. Nice little thing, like that would save me, I don't know, 1, 2, 3 hours every time I make an update. So this is a little tool and kind of a work in progress. And then similarly, this is the actual web application, and the actual web application consumes all of these microservices, and even the background process consume the microservices. So these are some of the major decision. And then here, if you see here, like the same connection strings. If I had settings file for each project, the same set of settings, the same connection strings would have to be in multiple places. So instead, what I did was have one directory where I put my settings, and all the applications read from the same directory, the same settings files. And as a matter of fact, as of now, this part is kind of a work in progress, but as of now, all the microservices and all the applications are reading the same from the same folder, the same settings files. But one of something I wanted to do as part of like kind of for future enhanceability is like I wanted to do some caching layer type of microservice, like kind of like my own version of distributed caching, and for providing app settings. So in the future, like over the next 1 or 2 releases, this particular microservice would act as the provider of settings. The reason is, like due to a lot of hacking related threats, and like the advanced spying capability of India's raw equipment. If I know the password, they would know the password. If I see the password on the screen, they would see this password on the screen, because they have little hidden drone kind of thing. What if the application, like what if this application rotates the passwords every few days, changes the passwords? I wouldn't know the password for the database. So these people, like these spies wouldn't know the password. And all the other applications would request this application for the password. This application would keep track of the latest rotated password and when was the last password rotated. And like these type of settings would be provided by this. And that way I would have some flexibility and some additional layer of security built into the application. So this is like something that would be implemented over the uh, within Q1 and Q2 of 2002. And there are several other things. Yeah, so see here, all of these are complete, and that's all. So now let's see. Mm, version history. Yep, there you go. That's all. Deployed. And because only the related podcasts, the gallery has, this is how the podcast details was in the earlier version. Now it would be slightly different. But yeah, I thought it would be nice, like kind of, so when like when the first version was released, this is how the application looked. And like if you see, the header colors were different. Now the header color is different. I thought it's a nice little thing to see the like how the older version looked, especially like 3 years, 4 years, 5 years down the road. It would be a very nice kind of nice memory to see how the application evolved over the years. So this is the gallery feature. Yeah. Yes. So anyway, coming back to this. So yes, this is one of the thing I'm planning to do, and I don't know if you saw this or not, but mm, yeah, yesterday I made an announcement regarding Q1 and Q2. So this is like some of the action plans, rotating and auto-generated password tools, monitoring, alerting, NIST cybersecurity framework, and like I personally want to study and get certified in AWS database and AWS security. So like once all of this is done, I can allow users to register on PodDB. Like subscribe for podcasts, like maybe add comments, things like that. I can start storing user data with confidence. Although I know I'm the target of these raw spies, research and analysis wing spies, and I know the capabilities of their equipment. And for all practical purposes, they are psycho sadists. So yeah. So in other words, I'm securing my application so that although like I'm spending some time, for, I don't know, like 6 months, 7 months, trying to secure the application. But yes, definitely, over the long term, all of this effort would be very useful. Uh, yeah, with that, I'm ending this broadcast. Mm, Thank you, everyone.